Hi class, this is section 5.5, properties of parallelograms. And just to remind you, we did this definition in chapter 1, but a parallelogram is a quadrilateral or a four-sided figure with both pair of opposite sides being parallel. A rhombus, a rectangle, and a square are all types of parallelograms. So more specifically than just a parallelogram, it could be a rhombus, rectangle, or square. We're going to study characteristics of parallelograms in this section. In 5.6, we'll look closer at rhombi and squares and rectangles. So to start off, I'd like for you to open Sketchpad, and we are going to construct a parallelogram. So we want to make sure both pair of opposite sides are parallel. So I'm going to start with 3 points, and then I will construct a line, and then highlight that line in another point and say construct parallel line there. And then we want to make sure that the other lines are parallel as well. So I am going to highlight these 2 points, and then highlight this one, and then construct parallel line this way as well. So now with those 4 points, that will make the figure. And so now I just need to make sure I construct the segments. And then I can hide the parallel lines. Uh-oh. Okay, so there's our parallelogram. The first thing I'd like to do is measure the 4 angles of the parallelogram. So I'm going to highlight the angle and measure it. And I'm going to go around and measure all 4 of them. And we're going to look at the characteristics of the angles. Oh. Okay, so just looking at the measurements there, it's pretty clear to see that our opposite sides, opposite angles stay congruent, no matter how you move it around. Okay, the other thing I'd like to look at here is the lengths of the opposite sides. So I'm going to highlight my 4 segments, and I am going to measure the lengths. And it appears that opposite sides are equal in length. Another thing I'd like to look at is the relationship between the consecutive angles. So I'm going to open up my calculator, and I am going to take angle B and add to it angle A. Those are called consecutive angles because they're one right after another. And look, they are supplementary. So A and B are supplementary, and since A and C are equal, that means B and C are supplementary, and then C and D are also supplementary. So consecutive angles are supplementary. And then we're going to do one more construction here. I'm going to construct the diagonals. Now, it's pretty clear that the diagonals don't have to be equal in length. You can make one diagonal much longer than another one. So that's not going to be what's special about it. But what happens is, make segments here, construct segments, and then measure them, you will see that something special occurs. So you can see the two segments EB and ED are equal in length, and then CE and EA are equal in length. So the diagonals bisect one another. They're not equal in length, the two diagonals aren't, but they bisect one another. So we can put congruent marks on those. And we should also probably put congruent marks on the sides, the opposite sides. Okay, and then I can also mark that the opposite sides are parallel, so that we remember it's a parallelogram. So those two sides are parallel. And there we go. So let's go ahead and copy this and put it in our notes. And then we can write our conjectures about a parallelogram. Okay, the first one, parallelogram opposite angle conjecture. The opposite angles of a parallelogram are, and let's go back and remember, angle B and angle D are opposite. Look, they're the same exact measure. C and A are the same measure. So the opposite angles of a parallelogram are congruent. Okay, so that's the first conjecture. Please put me on pause and make sure you get these notes into your notebook. The second conjecture is the consecutive angles conjecture. The consecutive angles of a parallelogram are, if we go back and remember, we took angle B and added it to angle A because they would be consecutive angles, and they summed up to be 180. So the consecutive angles of a parallelogram are supplementary. The third conjecture has to do with the measures of the sides. The opposite sides of a parallelogram are, and if we go back and look at our picture, we can see that they are congruent. We already know they're parallel from the definition. So opposite sides of a parallelogram are parallel and congruent. And then the last conjecture has to do with the diagonals. So the diagonals of a parallelogram bisect each other. And there you have it. There are the 4 conjectures concerning parallelograms. So that will apply to every square, rectangle, rhombus, or just plain old parallelogram that you have to deal with. You need to remember those 4 things about them. Okay, I'll see you in class.